Good afternoon, friends or students. Today we come to start our next session on Brayton cycle. Previously studied about Otto cycle, visual cycle, dual cycle. Now today we comes to Brayton cycle. Previous time we said that the cycles, reactor cycles are mainly used in automotive sector, but this cycle may be used in industry also. How? First, we say about the cycle by through diagram, that means PV diagram and TS diagram. You see that's here also the four processes there. 1, 2, 3, 4. And you see that here for Brayton cycle both 4 to 1 and 2 and 2 to 3. Are constant pressure heat addition and heat rejection. In our Otto cycle, we see that there is two heat addition, heat rejection process which is happened in constant volume, but here this is happened at constant pressure process. That means process 1, 2 adiabatic, compression, process 2, 3, constant pressure heat addition, process 3, 4, it's adiabatic, expansion, and process 4, 1 constant pressure heat rejection. Then first we look up about the constant pressure heat addition, which is denoted by Q1, right? Then what will be the formula here? It must be M, as it is happening in constant pressure, then we go for Cp into the difference in temperature at the start of the process, at the end of the process. That means which is higher? It is T3 minus T2. And similarly for the heat rejection, it must be M, C, P, then temperature at the start of the process, temperature at the end of the process, T1. Then what will be the efficiency of the Brayton cycle? It must be one minus Q2 by Q1 that means 1 minus heat rejection by heat addition. Why this looks like that? Because what amount of compression is happened and what amount of heat is added, on the basis of which we get the combustion, that means heat addition means combustion, and due to combustion what amount of heat combustible product is generated, and this combustible product is used as a power stroke, and then the what amount of this undesired combustible products is goes down from this engine, it is known as the heat rejection. Then 1 minus, what is the value here? M Cp T4 minus T1 by N Cp T3 minus T2. So what will be our comes, as the value of M is not 0, then this is comes like, looks like that, T1 T3 minus T2. Now this is one part, and you see that the equation almost looks like whatever we get in times of Otto cycle, because the efficiency of Otto cycle also comes out that 1 minus T4 minus T1 by T3 minus T2. Then we can say the efficiency of Brayton cycle is almost equal to the efficiency of Otto cycle in terms of heat addition and heat rejection. Now we must look that what will be the efficiency of Brayton cycle in terms of what? That compression ratio. Now go for that portion. Which is denoted by R suffix K. Now, for if you go to the previous slide, whatever we get that, from the graph you see that it's 1, 2, 3, 4. Process 1 to 2. What kind of process this? This is an adiabatic process. As this is an adiabatic process, what can we write for process 1 to 2? As it is adiabatic process, what can we write? We can write that T2 by T1 is nothing but P2 by P1 to the power gamma minus 1 by gamma. This is also an adiabatic process, which is in turn known as power stroke. Here also T3 is not T3. T4 by T3 is nothing but P4 by P3 to the power gamma minus 1 by gamma. or we can write T3 by T4 is equal to P3 by P4 to the power gamma minus 1 by gamma. Now we go to the first line. That means from there you see that whatever we get at P3, that is pressure at P3 is same as pressure at P2, because there is no change in pressure, there is parallel. Here also, where the pressure at P4 is same as pressure at P1, as there is no change in pressure from the graph we can see. Now whatever we get here, that is T3 by T4 is equal to what we write? We can write P2, and for P4 we can write P1. Then we get gamma minus 1 by gamma. Now we know just T2 by T1 is equal to P2 by P1 to the power gamma minus 1. This is same. Now, or we can write T3 by T4 is equal to T2 by T1 as T2 by T1. We previously found that P2 by P1 to the power gamma minus 1 by gamma, and here also P3, P2, P4, P1. Now as T3 by T4 is equal to T2 by T1, we can write then T3 by T2 is equal to T4 by T1, or we can write T3 by T2 minus 1 is equal to T4 by T1 minus 1. We make minus 1 in both sides. Then there is no change in that value. This thing is same. Now we come to T3 by T2 minus T2 is equal to T4 minus T1 by T1, or we can write T4 minus T1 is nothing but T3 minus T2 T1 by T2. Right? Now what we can write? T1 by T2 as per compression ratio. What is that? As per compression ratio, what is that? What can I write? We get that T1, T2. It's okay, no problem. If it is T1, T2, then what we can write here? Now we can write T4 minus T1, T3 minus T2 is nothing but what? P1 by P2 to the power gamma minus 1 by gamma. As previously we see that T2 by T1 is equal to P2 by P1 1 by gamma. No problem. Then from here what we can write? If it is P1 by P2 the gamma minus 1 by gamma, then what? How we can get it into the terms of compression ratio. We know the compression ratio, that means Rk is equal to nothing but V1 by V2. Then how we can find from that? It is nothing but T4 minus T1 T3 minus T2 is equal to what? Is equal to nothing like that. It is V1 by V2 to the power gamma minus 1. That means, sorry, pardon me, it is V2 by it is V2 by V1 to the power gamma minus 1, or we can write from that it is equal to 1 by V1 by V2 to the power gamma minus 1, or we can write 1 by Rk to the power gamma minus 1. That means we get the efficiency of Brayton is nothing but 1 minus 1 by Rk to the power gamma minus 1, which is equal to the efficiency of Otto cycle.